Okay, so we're going to use the log laws to be able to solve for x of this particular equation. We have the natural log of x squared minus the natural log of x plus 4 is equal to the natural log of 2. And remember, what we want to try to do here is we want to try to combine together as many of these logs or natural logs as we can. So because these two have the same base, they're log base e, right? Remember, that's what natural log means. Right? We can use this second log law over here, right? So this log law means that we can take this and rewrite it as the natural log of x squared divided by x plus 4. Okay, and we'll leave that right-hand side the same. Now in this particular case, notice we have a natural log on both sides of the equation. So couple ways to think about this. One is to say, okay, well, if we wanted to get rid of the natural logs on both sides of the equation, we could just do e to the power of both sides, and then the e's would and the natural logs would cancel to leave us with x squared over x plus 4 is equal to 2. The other way you could think about it is you could say, okay, well, if this is the natural log of this stuff and it's equal to the natural log of this stuff, then the two stuffs have to be equal, right? So however you want to think about it, as long as you're getting to there. So then from there, we can multiply both sides by x plus 4. Okay. Now remember, on equations like this, right, if there's an x squared term and some x terms, let's simplify a little bit more by expanding this through 2x plus 8. Then from there, remember, if there's an x squared term and an x term, we have to move all the terms to one side of the equation, right, and set it equal to 0, or so that there's a 0 on the other side. Okay. So for example, right, we've got x squared, we're going to subtract off the 2x to this left-hand side, subtract off the 8, and that leaves us with 0 on that right-hand side. Okay, and then the trick is to get this to factor. So we're looking for two numbers that multiply to give minus 8 and add to give minus 2. So those two numbers are x minus 4, x plus 2. Those are the two numbers that multiply together to give the minus 8 here and add together to give minus 2, which means that we've got two sort of potential solutions here. The thing that makes the x minus 4 equal to 0, which would make this whole equation equal to 0, is x is equal to 4, and the value of x that would make this second thing equal to 0 would be minus 2. So those are our two sort of potential solutions. Now, we always want to sort of go back and check, right? Because answers we get here at the end, they might not be okay when we go to plug them in here to this original equation. Remember, if we take the natural log or log base whatever of anything, they have to be positive numbers here, right? So we better check that when we plug in these values that they give us positive things inside those natural logs. So when I take 4 and plug it in here, 4 squared is 16, definitely positive, no problems there. And if I plug in this 4 here, right, I get 4 plus 4, which is 8, positive, no problems there. Okay. Then we better check the same thing with the minus 2. So the minus 2 squared gives me a positive number, positive 4, so no problems there. And when I plug in minus 2 into this equation here, we'd have minus 2 plus 4, which is positive 2. So again, no problems. So I've checked both of those. They're both okay, but it's always good to sort of check because, you know, if we had gotten another answer here, I don't know, let's say we didn't, but let's say we had gotten, you know, minus 8 or something like that, right? If I were to take minus 8 and plug it in here, okay, fine, no problems. We still get a natural log of a positive number. But if I plug in minus 8 here, right, I'd have minus 8 plus 4, which would give me minus 4 inside that natural log, which would give me an error, right? Remember that natural logs or logs, we don't know how to take those of negative numbers. So if this had been a solution, we'd have to sort of ignore it. But in this case, that was sort of a hypothetical example. In this case, our two solutions were both okay when we plugged them back in.